Hi, welcome back. Today we have a question which is the uniform 5-meter long round wooden rod is tied to the bottom by the string. As you can see in the figure there. Determine the tension in the string and secondly specific gravity of the wood. Alright. So the first we need to understand the concept. What's the question asked? Okay. The tension as well as the specific gravity. So from here, we need to draw the free body diagram. So we can draw the string will have the tension, okay, downward, which is T. And then we have the weight of the block, which is acting at the center of this wooden. This is 5 meter total. 4 plus 1, 5. Definitely here to here is 2.5 meter. So we have the weight of the root, as well as we have the buoyancy force, because only this portion from here to here submerged into the water. Definitely the buoyancy force will act at the centroid of the submerged body. This is FB. So based on this free body diagram, we can do the equation of summation of force in y direction is positive equal to 0. We consider this is floating under equilibrium state. So what's the force involved? We have FB pointing upward. And then we have T pointing downward, negative. As well as we have the weight of the rod equal to 0. So the question asks tension. So we should make the tension as the subject, which is equal to FB minus weight of the rod. So first we need to find the FB. So FB by the formula is gamma of fluid multiplied with the volume of displaced fluid. Okay, displaced fluid. So only this portion from this part into this end is 4 meter. So only this portion displaces the fluid. So based on this, we can have the cross-sectional area with the volume. Okay. This is diameter is actually 8 centimeter. Okay. And then the length here is 4 meter. So what's the volume? Okay. This is the volume of displaced fluid. So based on this, we can get the volume of displaced equal to area, which is area multiplied with the length. So what's the area? Pi r squared multiplied with the length. So radius, in this case, this is 8 centimeter divide with 2, which is 4 centimeter. Convert into SI unit, divide with 100. So 0.04 meter. That is the radius. So gamma of fluid given by 9790 multiplied with the volume of this, which is area pi, radius squared is 0.04 squared multiplied with the length, which is 4 meter. Okay, based on this, we discover that the buoyancy force is equal to 196.84 Newton. So how to get the weight of the rods? Alright, so for this case, we can apply the moment. Alright, summation of moment, positive anti-clockwise at point T. Let's say this is at point T equal to 0. So start from here at this point. Okay, from here to here. Okay, we have the angle theta. Okay, this is, let's say, this is the FB in X direction. Okay, so for this case, okay, from here to here is, what's the value? Is 2 meter. Because this here is 4 meter, divide with 2 is 2 meter. So, you try using your right hand rule and then follow your FB. It is anti-clockwise. Sorry, it is clockwise. Your thumb facing into the page. So, it is negative FB. Okay, because this is considered as the, okay, this angle same with this angle. Okay, if you learn the trigonometry, right? Because from here to here, sorry. Okay, this angle will have a this angle. Okay, this is the width. Okay. Okay, from here we'll have this angle. Okay. Alright. This angle is the same with this angle. Right? This angle is the same with this angle. Alright. So for this case, in order to get FBX, you have to do the cos. Cos theta. Okay. And then proceed with the WX, which is downward from here, going to W. Okay. Let's say this is WRX. Okay. So for this case, WRX. Okay. So follow your right hand rule and then curl following to the WRX, you will get positive because your thumb facing upward. Positive WR. Okay, it is cos theta as well in order to get this. Okay. This theta same with this theta. Okay, in order to get this cos. Okay, horizontal. And then equal to, alright, and then equal to, do we have any other forces? Okay, and then equal to 0. So cos with cos we can cancel down, and what we left here is, alright, width of the, sorry, FB is equal to the width of the roads. Okay, so we have this one. Okay, for this part, you need to make sure you multiply. Okay, you need to multiply with the okay. For the summation of moment, we do at point T. Alright, so start with the FBX. FBX is, follow your this point at point T to the FBX is, what's the distance here? It is 2 meter multiply with the FB, and then in order to get this X direction, okay, cos with angle theta. And then for here, we have the one more, which is WRX, which is from here to here is 2.5. Okay. But make sure the FBX, you can see from point T to FBX is, and then you try to curl your hand, it is down into the pitch. So it is negative. And for WRX, it is positive. Follow your right hand rule from here and then try to curl your hands. It is positive. So the value here is, okay, 2.5. 2.5 multiply with the WR cos theta equal to 0. Because this angle will have the same angle with this. In order to get this, you cos it. So what you found here, you cancel cos with cos, and you will get 2.5 WR equal to 2FB. So WR equal to 2 over 2.5 FB. So in order to get this tension force, okay, the FB minus with WR, which is 2 over 2.5 FB. So what you can do, factorize FB. FB equal to 1 minus 2 over 2.5. Okay. You can calculate 2 over 2.5. 1 minus this is 0. Okay, you can get 0.2 FB. Thus, your buoyancy force, this value, which is 0.2 multiplied with 196.84 Newton. Okay, 196.84. So your final answer of the tension to be 39.37 Newton. Right? Okay, next the question asks the specific gravity of the wood. Okay, how to get the specific gravity of the wood? This is question B. Okay, of the wood, which is the density of the wood over density of the water. Okay, so for this case, the density of water we know already, 1000. And the density of the wood, where the density equal to mass over volume. Okay. So, the mass here is directly we got from the weight of the wood. Okay, weight equal to mass multiplied with gravity. In order to get mass, weight divide with gravity. So replace here with the weight over gravity. Then you will get density of the root equal to the weight of the root over gravity multiplied with the volume of the total root. So what is the weight of the root? This one we discover, which is, alright, 2 over 2.5, this is point, multiply with the FB, which is 196.84 over gravity 9.81, multiply with the volume, the total volume, which is pi. We need to find the cross-sectional area of this, and then multiply with the whole length, which is 5 meters. So pi multiply with the r, which is 0.04 squared, multiply with the length, which is 5 meters. Okay, try to solve this one. You will get 196.84 multiply with 2 divide with 2.5. You will get here to be 157.47 over with the volume, which is pi, multiply with the 0.04 radius, multiply with the 5, multiply with 9.81. So here you will get 0.247. So the density should be 157.47 divided with 0.247. You will get 8.69 kilogram per meter cubic. Thus, in order to get the specific gravity of the wood, density of the wood, which is 638.69 divided with 1000. So you will end up with 0.6387. Therefore, that is the final answer.